Suppose that the weight of navel oranges is normally distributed with a mean of 8 ounces and a standard deviation of 1.5. So the original population is bell-shaped, mean is 8, and standard deviation is 1.5. So the average weight of an orange is 8 ounces. With it could vary 1.5 up or down standard deviation. What proportion of the oranges weight more than 11 ounces? Or if you randomly select a navel orange, what's the probability that its weight is more than 11.5? We've done this before. It's only one orange, guys. We're not working with samples yet. That comes toward the end. So it will be probability of X more than 11.5. Okay, can a student complete the rest here? So what would that be? Normal CDF of what? We need lower, upper, mean, standard deviation. What's the lower here?
11.5.
Correct. What's the upper?
1,000,000.
And then the mean is
8.
8. Standard deviation is 1.5. As simple as that, guys. That's how we've done it, and that's how we're gonna do it. And let's do the answer.
Professor, I'm confused. Like, how do you know if it's population or sample?
Oh, well, because he says we picked one at random. When he says select one thing, it's always, just working out of the population. You're gonna see later in part E where he says if 9 oranges were selected. So you will see the difference.
Okay.
When he gives you a sample size, then we're working with samples. He didn't, it just select one item, you're still doing it out of the population. Does that make sense?
Yes, thank you.
Yep. All right, let's do this, guys. So lower is 11.5. Put a million. Put the mean. Put the standard deviation and paste. Okay, so I got 0.0098. Let me just make sure that I got the correct numbers. Yeah, 11.5, 1,000,008, 1.5. Yeah, just making sure, guys. So 9.8. So guys, let me ask you a question. Is it likely that you pick an orange and it's gonna have a weight of 11.5 ounces or more based on the answer that we got? Yes or no? That's what you need to understand about probability. This probability is very low, guys. If you change it to a percent, it wouldn't be even a 1% here. It will be 0.98%, almost a 1%. So the chance is very low. If you pick an orange and measure its weight, it's very unlikely that it's going to be more than 11.5% because the chance is very low. When he says what proportion, it's a probability, it's a percent. So the chance of picking an apple that turns out to be 11.5 ounces or more is a very low chance. This is very unusual here. It's called unusual event because it's less than 5%. What proportion of oranges will weigh less than 9.7 ounces? So it's the same question as part A, guys, but it's a less than. Okay. Would a student tell me what are the 4 arguments here? What's the lower bound?
Negative 1,000,000.
Negative 1,000,000. Again, guys, you can use this as a model for all the work you do. This is the more than model. This is the less than, and you can see part C, it's going to be in between model. 9.7. And I guess everybody should know that's the mean and that's the standard deviation. So let's see what's the likelihood, guys, that you pick an orange and it's going to be less than 9.7. I think probably there's a better chance for this. Let's see. Normal CDF, negative 1,000,000, 9.7, 8, 1.5. We don't change those. Okay, see, 0.8715. Okay. C, what's the probability of selecting an orange that weighs between 9.2 ounces and 11.7 ounces? And guys, you know, you write in between like this, 9.7, 11.2. And it will be normal CDF. And guys,
Is it X bar?
no,
Or just
X, X.
Okay.
Only X bar if you have a sample size more than one. He hadn't talked about sample size yet, as you notice. I'm glad
Professor-
you're asking those questions, guys, so I can unmute you.
Professor, you
well-
wrote 9.7.
What is, oh, 9.2. Let me see.
And then it's 11.7.
11.7. Oh, I mixed them up. Yeah. So that will be normal CDF, 9.2, guys. 11.7, mean is 8, and 1.5. I just want to show you guys how consistent we have been this week with this lesson. I'm not doing anything new. It's the same problems, just knowing, reading the problem carefully, and just use this popular function, normal CDF or inverse norm. That's all you do in this chapter. So it's going to be 9.2. Always the smaller number, guys, comes before the larger one. So the lower is smaller and the upper is larger, always. 11.7 and mean and standard deviation, paste. 0.2050. What I suggest, guys, just redo this problem on your own, and you already have the video or the answers. Check the answers before even you do any work. So if you do it right, that means you're ready, you know, just to take care of all the problems, homework problems, and this. Okay. D. Find the 80th percentile of the distribution of weights of oranges. This question can also be asked as follows. Find the values of x below which you find the lightest 80% of all oranges. Okay, here's the sketch, guys. What would be the weight for which 80% of all oranges are less than that weight? You know, guys, that the 50% is right here. So 80% has to go right here. And this area is 80%. Let me just do it in red. He wants this X value, which is the weight of an orange. So what would be the weight of an orange for which 80% of all the oranges are less than that weight? And you guys, as I told you last time, if he gives you the probability and he wants the X value, you cannot use the normal CDF, because the normal CDF is used to find a probability. You have to use what we call the inverse norm. And the inverse norm, guys, require 3 arguments. Area to the left of my target, mean, and standard deviation. And he tells you, once he says 80th percentile, that means the area to the left is 80%. 70th percentile, the area to the left is 70%. So we already know what the area is. And you put 8 and you put 1.5. And let me show you how to use this. So the first 3 parts were section 5.2. Part D was section 5.3, and then we're going to move probably to section 5.4 after this. Not normal CDF, inverse norm, sorry. 0.8. Mean is 8. Standard deviation is 1.5. And watch, guys. 9.26 ounces. Okay. E. Now we're back to central limit theorem we just did this morning. Look the difference, guys. I know a couple of students ask me what is the difference, when do we know, and we use sample size. Look what it says here. If 9 oranges were randomly selected, not just one orange, so we have a sample size, guys, so it's n equals 9. Once you see a sample size, remember your standard deviation is not going to be the same standard deviation, it's going to be divided by square root of n. What is the probability that their mean weight, look, it says mean weight, which is x bar, that's the reference for mean weight, is less than 11.2. So instead of putting x, guys, you put x bar here, 11.2, and normal CDF. Now you can help me, guys, with the 4 arguments. What would they be? Lower bound. No changes, same lower bound as before. So what would that be here? Negative a million. Upper bound 11.2. Mean is 8. And I'm going to use red for standard deviation. We're not working with the original population. We're working with the sample means population. So it's going to be not 1.5, guys. It's going to be 1.5 divided by square root of 9. That's the big difference between working with samples and working with individual oranges. So that would be the difference here. And if you want to do the math, second, distribute negative a million. What do we have? 11.2. Mean is 8. And standard deviation, watch me, guys. 1.5 divided by square root of 9, which I know it's a 3, so I'll just put 3 here. Any questions before I hit paste? Okay, 0.9999, almost 100%. If you round it, it's going to be 1. So you can guarantee, guys, if you pick any sample of size 9, the chance that you're going to get an orange that has a weight of 11.2 ounces, 100%, almost 100%. Okay. Next, F. If 17 oranges are selected at random, so n is 17 now, I'm changing the sample size. And remember, guys, once you see a sample size more than 1, the question is not going to be about x, it's going to be about x bar. What's the probability that their mean weight? Watch, guys, it says mean weight is more than 12 ounces. Okay. Would someone tell me what the 4 argument here? I know how to do them myself. So what would they be? What's the lower bound, guys?
It would be negative a million.
It's a greater than 12.
12.
Oh,
12, yes. Then a million. Remember, greater gives you the billion here. Less than gives you the negative million at the very beginning, always. And then I'll put as many zeros as I want. And then I put 8. And in red, guys, so you can see it clearly. Now 1.5 over square root of 9. My sample size is not 9 here, it's 17. Square root of 17. And here we go. Let's put it into the calculator. Second, distribute. Normal CDF. So you get a 12 million 8 1.5 divided by square root of 17. And watch me put the square root of 17 here, close parentheses, paste. That's what I have on my screen. And that's what I require, guys, that you show when you do your assignment. This, I want to see this. That's why I put an example showing you how to do the form, etc. Just show me the 4 arguments that you put in the formula. Enter. And look what it says, guys. You have to pay attention to this. It says 2.07, and there is an E minus 28. No, we don't have to use a million. Use any number that is very, very large. Put 10 zeros, 15 zeros. Don't put 1,000. 1,000 considered small in some cases. Just use as large as you can. And guys, please don't ignore the negative 28 here, because if you ignore it, you're going to put an answer of probability of 2.07, which is impossible. A probability cannot exceed 1. Once you see an E with a minus, guys, that means your answer is 0. E minus 28 means you have to move this decimal point 28 digits to the left. Well, if I move it 28 digits to the left and I round to 4 decimal places, it's going to be 0. That's the answer. So if you pick 17 oranges, guys, and take their average, take their mean, so measure them and find, the mean of the 17. It is impossible almost that their average of the 17 oranges is going to be more than 12 ounces. It won't happen. It's not going to happen. And 8G, last part. What would be the minimum weight of an orange that place it in the top 10% of weights? Once he gives you a percent, guys, he's giving you the probability he wants the X value. So top 10%, guys, where would you shade for top 10%, left or right?
Right.
Right, I agree. Don't shade more than 50% because 50% is the center. So shade toward the tail. That's 10%. And he wants this X value. So who's going to help me with the inverse norm? What would be the arguments here?
1 minus 0.10.
Exactly. And then mean is 8. Standard deviation is 1.5. Now, if some of you have calculator, guys, I don't. Mine doesn't do that. If some of you in the inverse norm have a feature that says right, left, center, let me know. I can show you how to use this properly.
I
But-
have it on that one.
Okay, so in this case, look what you can do. Instead of doing 1 minus 0.1, you just keep it 0.1, but tell the calculator that you're doing a right tail. So just choose the right. It will do it exactly the same way as we're doing it right now. But if you want to keep your calculator set to the left, just like the formula that I'm using, you can keep it left and just do what I'm suggesting you do here. So this calculator, my function here requires the area to the left. Now, if some students are wondering why we did 90% instead of 10%, 10%, guys, is the area to the right of my target, but the calculator wants the area to the left, and this is a 90%. Or 0.9, that's why we put 1 minus 0.1, 8 and 1.5. If you don't do the 1 minus, you will get an answer that you should know it is wrong, and I'm going to show you why. How do you know if this answer is wrong? So inverse norm, 0.9, mean is 8, standard deviation is 1.5, paste, 9.92. Yeah, it's reasonable. The average is 8. That's more than 8. That's a top 10%. But let's say, guys, you mistakenly did not do 1 minus 0.1 and you got an answer. Let me show you that the answer should not make sense. Inverse norm, 0.1. Oops, sorry. 0.1. 6 ounces. How could an orange be a top 10% weight and its weight is below the mean? That's not possible, guys, because the mean is 8. That's below the mean. So that's not a reasonable answer. That is a low 10%, the lowest 10%, not the top 10%. If it was asking me what would be, just weight, just the low 10%, that would be the correct answer. But the top 10%, it has to be above the mean. And that's why if you just keep the 0.1 would not be correct. Okay, so